I'm going to do 10-minute timed conversations with ChatGPT to try and develop, at the moment, a very simple refresh token JWT flow, and then show its usage in React using state machines. So let's go ahead and try. Hello, I would like to put together with you a X state machine for handling JWTs and refresh tokens if the JWT is expired. And a JWT is expired or invalid if we receive a 401, a 403, a 405, or a error true in requests made with that JWT. That will be a function we use in the state machine, but the state machine is going to talk through the various different states and events that the state machine can handle. So we're going to have a request that we'd like to make. We've got some parameters. It's just a normal HTTP request. And I want the state machine to be in charge of walking through the various steps of idle or instantiated. And I would like your help here as well, because if my familiarity with the specification is flawed. In fact, what I would like you to do is please ignore pretty much most of what I've just said. You can address it if you'd like, but rather tell me what the events and states of a state machine would look like that implemented a JWT refresh with a refresh token flow. Obviously, we're not going to handle every single error that could occur. Let's assume 200 is success, 401, 403, 405, and a response with an error true would constitute a failed request that require a refresh. And let's go from there. What am I missing? Help me understand what I'm missing, and then we're going to implement it. Designing a state machine for handling JWTs and refresh the tokens in a scenario where JWT might expire or be invalid is a great approach for managing secure, authenticated requests in your application. Here's an outline of the states and events such a state machine might include. Idle, the initial state where no active request or token refreshing process is happening. Requesting, state where a request is being made using the current JWT. Awaiting refresh, state entered when a JWT is expired or invalid and a token refresh is needed. Refreshing token, state where the refresh token is used to obtain a new JWT. Success, state indicating that the request was successful. Failure, indicating that the request or token invalid. Refresh failed. I think in reading through the states, I wonder if we should add some context here for each state, or at least overall context for the machine. Because retry request or token refresh failed, triggered to retry the original request of the new JWT. Okay, yeah, sure, okay. So in reading through, I think the states look good. state indicating that the request or token refresh failed. I don't think we should have that or in there. I think that or should be represented by context, and we should have a failure, and then that's either the request failed or the token refresh failed. I think that's good information to have. Then I'm going to read through events. Make request, triggered to make a new HTTP request. Request success, triggered when a request returns a 200 response. Request failed, triggered when a request returns a 4140345 response or a error : true. Token refreshed, triggered when a new JWT is successfully obtained. Token refresh failed, triggered when refreshing the JWT fails. Retry request, triggered to retry the original request with the JWT. Transitions, idle to requesting, triggered by make request. Requesting success, triggered by request success. Requesting awaiting refresh, triggered by request failed. Awaiting refresh, refreshing token, automatically triggered to start the token refresh process. Refreshing token to requesting, triggered by token refresh to retry the request. Refreshing token to requesting, triggered by token refreshed to retry the request. Okay, yep. Refreshing token to failure, triggered by token refresh failed. Any state failure as a catch-all for unexpected errors. Consideration, error handling. Ensure robust error handling, especially in refreshing token and requesting states. Retry logic, implementing a limit on retries can prevent endless loops in case of continuous failures. Security, ensure that the refresh token is stored securely and is only sent over secure channels. Timeouts, implement timeouts for token refresh and requesting retries to handle network issues. Logging state transitions. This is a simplified model and needs adjustment based on specific requirements or constraints in your application. For instance, you might want to add more detailed substates or handle other HTTP status codes differently. Once you have the basic structure, you can implement it using XState or similar state management library, mapping these conceptual states and events to actual code. Okay, great. So I've just finished reading that aloud, and I think it looks good. I want to visualize it to be able to actually say, yep, this is good, or that I'm missing any error cases. I do think I would like to have add into context there. Let's talk about context, and then we'll go ahead and create the machine. In the context, I think it would make sense to have things about, retry count, retry max count, maybe a mapping of timeouts, depending on what state you're in, that we should go to like the timed out state. Maybe some, this isn't in context, but it's just relevant here. Maybe some information about, if the network is active or not. Maybe there should be like a child machine that is responsible for, that is responsible for determining whether or not the client is connected to the network at the moment with some kind of network monitor that is a subscription of some sort. And so, let's talk about the context. Let's talk about anything else that we should handle briefly, and then we'll get to actually building the XState machine. So what I'm trying to do with this whole process is show my process for learning. I need to relearn how to learn because I've forgotten how to learn. ChatGPT is a great resource for that, but it's still not great because it makes things up. I'm going to go ahead and send that in. Let's break down the context and any additional considerations before moving to implementation phase. Retry counts. Store the current number of retries for both the request and token refresh attempts. This helps in implementing retry limits. Max retry count. Define maximum amount allowed retries to prevent endless loops. Timeouts. Map timeouts to different states or actions. For example, a shorter timeout for a token refresh versus a longer one for a network request. I don't know what a network request is exactly. Network status. This could be a Boolean flag or more detailed status indicating if the client is currently connected to the network. Original request parameters. Keep details of the original request that failed due to token expiration for retrying after refreshing the. There's a 10-minute timer, so I'm going to go into one more of these, and then I've got a meeting at 1:24.